Let's factorize some quadratics. We have x squared plus 5x plus 6. Taking an x squared tile and 5x tiles and 6 unit tiles. I have a system. I know that my factorized form will create a perfect rectangle. So I need to arrange my system into a perfect rectangle if it will factorize, and I've made this so it does factorize. We would do examples that don't factorize as well. So here we have a factorized form of x squared plus 5x plus 6. And we can see that one of the lengths is x plus 2 and the other length is x plus 3. So we have x plus 2, x plus 3. By doing lots of these examples, children will soon spot and start saying to you that these two numbers here always multiply together to give this number, and these two numbers here always add up to give this number. And of course the image shows you exactly why that has to be true. The only way we can create a constant term is by multiplying these two numbers together. And the x terms come from these parts here, which will be an addition. Let's look at another example, 2x squared plus 5x plus 2. We have a system, 2x squared plus 5x plus 2, and we need to arrange our system to create our perfect rectangle again. So here we go, 2x squared plus 5x plus 2, a little bit of rearrangement to do that, and I can see I've created my rectangle. One of the lengths is 2x plus 1, the other length is x plus 2. And all of the relationships are in this image. This does give me 2x squared plus 5x plus 2 as an area, and 2x squared plus 5x plus 2 divided by 2x plus 1 would be x plus 2, and 2x squared plus 5x plus 2 divided by x plus 2 is 2x plus 1. And 2x plus 1 multiplied by x plus 2 is 2x squared plus 5x plus 2. Let's take a look at completing the square. X squared plus 4x plus 3. I want to complete the square. So I need to try to create a square with the system x squared plus 4x plus 3. I can't quite make a square. What would have to go in there to make a square? There's one missing. So this is almost a square. I have x plus 2 squared, but there's one missing. Suppose we wanted to do x squared plus 6x plus 8 divide by x plus 2. Let's rewrite this with more helpful symbolism. So x squared plus 6x plus 8, and we know that one of the lengths is x plus 2. So we're trying to find a rectangle, and one of the lengths is x plus 2, and the full system, the area, is x squared plus 6x plus 8. So I need to make one length x plus 2. Can I do that? Yeah. So I can take this one here and create a length of x plus 2. And now I need to keep this length constant. I've just removed x squared plus 2x from the system, and I have remaining down here 4x plus 8. And I want to make a perfect rectangle, which I can do. And you should be able to see that this question is precisely the same question as 168 divided by 12. It's just that this question is in base x, and 168 divided by 12 is in base 10. So I've just removed the final 4x plus 8. I have nothing remaining, and the other length is x plus 4. Suppose I have this system here, x squared minus x minus 6, which we have here, x squared minus x minus 6. And I know to factorize this, the factorized form would be represented with a perfect rectangle. No matter what I do with this system, I can't make a perfect rectangle. However, I can make this shape here. Initially, this might not look like a lot of help to the children, but suppose we remind them of zero pairs, and we ask, is it okay to add this into the system? Will this affect the system? Now we have a zero pair here, and clearly adding nothing into a system won't affect it. So I can add in that zero pair to the system. And I haven't changed it. That's still x squared minus x minus 6. I still don't have a perfect rectangle. Let's add in another zero pair. And I can add these zero pairs into here. Now I do have a perfect rectangle. And if I read across, looking at the colours, this is x plus 2, positive. This is x minus 3. X plus 2, x minus 3. Let's have a look at another example. 2x squared plus 5x plus 3 divided by x plus 1. Let's rewrite this with this symbolism. 2x squared plus 5x plus 3. We know now that we're trying to find a rectangle where one of the lengths is x plus 1. I could do this with algebra tiles, but this time I'm going to not use the tiles and simply use an image. We know there is some rectangle, some imaginary rectangle, and one of the lengths is x plus 1. We're working in base x, so that's an x and a 1 at some distance. If we go to the base, so x along, then we have x squared plus x. That's not enough. We're trying to find 2x squared plus 5x plus 3. So if we carry this along until we hit the base again, then we have another x squared and an x. So now we have 2x squared plus 2x, 2x squared plus 2x. And I'm trying to get 3x. I don't want to go another x along. I don't want to create another x squared. What I want to do is take a step of 1 along. Well, that's giving me an x and a 1. So I now have 2x squared plus 3x plus 1. Still not enough. Another 1 along. So I've got 2x squared plus 4x plus 2. Still not enough. Another 1 along. And I have 2x squared plus 5x plus 3. And the other length of the rectangle is 2x plus 3.